So, yeah, the awkward thing here is, okay, ladies and gentlemen, could we have a, maybe maybe I'll erase this and erase some of this diagram. Okay, so suppose we had, well, let me step back for a second. Suppose I have a flow, in. And, well, good. Think about this. So, one aspect of the one thing I might have represent a stock is position. Maybe it's position along some vertical rod, up and down, or whatever, right? There's position. This might be a flow of what? The flow into position might be. So suppose we're dealing with where a particle is along here.
What changes position over time?
Yeah, what changes position over time? It's velocity. Okay. The larger my velocity, the quicker my position will change, right? If the velocity is very small, it'll go slowly, it'll accumulate slowly, accumulate more quickly, right? Okay. And in general, if we have a stock and then a flow into it, the stock is the what of the flow. It's the flow is the derivative of the stock. The stock is the integral of the flow. Stock is the integral of the flow. It's that simple. So if we want to integrate up the size of the population over time, so a person years live. Okay, the size of the population here, and it'll be person years live here. We want to integrate up the earned income over time. We could simply have earned cumulative income over time and income here. In any case, so we have velocity. Now, could velocity be viewed as a stock? Because it's the integral of, yeah, so we could have a, and without, because they're going to be the same numeric, I'll just call them both velocity, although that's of course you need something different. And this flow into here would be what? Acceleration. So we could view actually velocity as a stock, and that would be associated with, in fact, momentum, right? Some mass times some velocity is in fact the momentum. This is where inertia comes in as well. Now, that's all well and good. That's perfectly easily done. And if Raheem were here, he maybe have done this already, to construct this. But what are the units associated with this? Kind of flies in the face of the chestnut I have, where something per unit time. Kind of smells like a flow, and in general that's kind of true. But what's the units of this? Well, maybe we're measuring it in meters. In this case, this would be, some number of meters from the base. Okay, so maybe we say meters. Velocity might be in meters per second, right? So this is meters per second, and acceleration would be in meter per second squared, right? So this would be that. Yeah, so, or you can think of it, for those puzzling over that, as meters per second. How quickly we're changing the velocity. So how quickly our meters per second, as represented by the velocity, are changing, right? Here, the velocity is actually it's actually a quantity that's per unit time. So you can get this in stock and flow models, and then it's perfectly consistent. It's not too common that you get that, but you can have it. The vast majority of system dynamics models, I've never seen this. I've not seen it, but occasionally I'll see a model which has it, and it's all fine. It's perfectly representative. It's just when I'm teaching rules of thumb for recognizing stocks and flows, often something that's in something per unit time is a sign of a flow. And in fact, this does serve as a flow as well. It's also a stock.
But if most models don't have that
Yeah. Yeah.
Does that mean that most models only deal with first order differential equations?
No. For reasons when we talk about, it's a great question, a fine question.
I'm good at the question, the answer goes
Okay.
I think with
Yeah.
velocity, can I say the stop or we will say this is the flow? Because when we measure any
Yeah.
positions,
Yeah.
actually based on the distance, how much distance comes.
That's right. How far the distance
Yes,
is?
and this distance is driving by velocity.
That's right. That's right. So you're right. I mean, is velocity here a flow? Yeah, it's serving us a flow in this capacity. It's bringing us a flow into position. Is it a stalk? Well, with respect to acceleration, it's a stalk. But you're right. It has the standard characteristic of flow that typically we measure it by measuring displacement per unit time, right? We measure.
Yes, distance is also meter cube per second,
Yeah.
right? Because we
Sorry, the distance.
distance
Uh,
unit is meter cube per second. That
Right.
is the V by T.
That's
the
right.
volume
That's right.
divided by time.
That's right.
Yeah.
Yeah. So the discharge of like a reservoir, you're saying, something like that.
Yes, distance should be in stop.
So,
Distance is driving by velocity.
okay,
Because when, suppose if we think this river is flowing,
yes,
so you say, okay, when more distance is coming,
Yeah.
the velocity is increasing.
I see. Yes, okay, I see what you're saying. You're saying that the volume, sort of a river can be viewed as having its velocity or rate of discharge, the rate of flow could be viewed as a stalk as well.
Yes.
I agree. I don't disagree with that. It's just that often we can represent that very readily in these models. It's just often those quantities further serve as flows also, because that discharge is coming out of a volume of a reservoir, for example, right? So you take the Lake Diefenbaker in Saskatchewan, the South Saskatchewan River flowing north from there is discharging that lake, and the lake has a volume, and that's an outflow from the lake. But can you view it also as a stalk with respect to other quantities? Yeah, you could. You could. It is serving as a flow, and it is serving as a stalk. It's just that most models that we see, it's going to be clearer cut than this. Okay, we're going to see model after model after model where we don't have this. Now, Kurt's question, though, is a different question, which is, does that mean we're dealing purely with first-order differential equations? And the issue is no. The answer is no. That doesn't actually mean that, because we could actually unpack a series of first-order differential equations, a sequence like it's behind an ODE, into a higher-order differential equation in a single higher-order differential equation, and it's not purely a single first-order equation. It's a system of equations, but I don't want to.
Partial differential equation normally we solve for this. When we are dealing with attachments of attachments.
That's right.
How much will be outflow?
Yeah. In this case, we're dealing with ODEs, ordinary differential equations, in a system of those rather than partial. But partial, if not only we had time varying, we're interested in varying over time in a continuous way. We're interested in varying over some x coordinate or a y coordinate and an x coordinate, and over time at the same time. And we're not going to be focusing on that issue. But if we're interested in those as continuous coordinates, or age would be another example, and if we were, then we could use partial differential equation. Okay. So great question. I think so we're dealing with some subtleties here, and I don't want to get lost, too much in these. As a general rule of thumb,